welcome to the Deep Dive. Today we're digging into a really fascinating chapter in baseball tech history.
Yeah.
The story of Easton's C-Core and Z-Core bats.
Ah, the legends.
Exactly. And this isn't, just about bats. It's about this technological, almost an arms race, really, that completely changed the amateur game.
It really did.
We're going to unpack the engineering, the materials, and the rule changes that shaped these things.
And what's amazing is how Easton, their background was in precision aluminum, archery arrows, even stuff for NASA.
Right.
So they were kind of perfectly set up to lead this. They knew tubes, they knew alloys. They just kept pushing performance limits.
So our mission for you today, we want you to really understand the physics, how C-Core and Z-Core came about, and then how the rules kind of slammed the brakes on it all.
Okay, so the key idea behind these hot bats is what's called the trampoline effect.
Right.
Unlike a solid wood bat, a hollow metal barrel actually flexes inward a tiny bit on impact.
Like a spring?
Exactly like a spring. It stores energy, then returns more of it to the ball. The ball compresses less, the bat does more work, higher exit speed. Simple as that. Well, sort of.
Okay, so it's acting like a spring. How do they make it a better spring? That's where it gets wild, right? This idea of hoop modes.
Yeah, hoop modes are basically how the thin walls of the barrel deform, kind of vibrate or ripple and spring back. And here's the crazy part, the paradox. Peak performance, the maximum trampoline effect, happened right at the edge, like the very precipice of the bat breaking.
Wow, so they were intentionally designing them to be almost too flexible.
Pretty much, pushing durability right to the limit for that extra pop. And that leads us right into the C-Core. This came out around 93.
Yeah, early 90s.
Easton's clever idea was bonding a carbon fiber sleeve inside the aluminum barrel.
Okay, so reinforcement from the inside.
Exactly. That internal sleeve supported the structure so they could make the outer aluminum walls even thinner and more flexible.
Maximizing that trampoline effect while trying to keep it from just, collapsing.
Right. And that was really the first mainstream multi-wall design, different layers doing different jobs.
And they kept tweaking the metal too, right? Better alloys.
Oh, yeah. Advanced alloys like C405, then SC500, which led to the famous Easton Red Line C-Core.
The red lines, man, that thing had mythical pop.
It did. But it was also kind of notoriously prone to cracking, usually up near the end cap.
Perfectly proves that point, right? Performance on the edge of failure.
Exactly.
Yeah.
So the Z-Core was the next step, refining that idea, trying to get better durability while keeping that high performance.
And the Z2K Z-Core, that's another legend. People still rave about that one.
Definitely. Many consider it one of the best ever. Great pop, but it held up better. It was like the mature version of the C-Core concept.
And at the same time, something else big was happening. The connection two-piece design. Around 99.
Yeah, the connection piece, that was huge too. It used this elastomer joint, kind of like a rubbery connection between the barrel and handle.
What'd that do?
Two main things. One, it killed that awful sting, the vibration you'd feel on mishits. Much more comfortable.
Okay, that's nice.
And two, it created the subtle whip effect, a little extra flex point that could actually increase bat speed for some hitters.
So when they put Z-Core and connection together.
That was it. You got bats like the Connection Z-Core. That was pretty much the peak of that whole performance era. The best of both worlds.
Okay, so how were these super bats even legal? What were the rules then?
Well, they were developed under the BESR standard, ball exit speed ratio.
Okay.
But BESR had this critical loophole. It tested bats when they were brand new.
Oh, and you said they got hotter with use.
Exactly. Manufacturers, Easton included, figured this out. They engineered bats to break in. Hitting balls actually made the fibers or the metal structure slightly more flexible over time, increasing performance well beyond that initial test spec.
So they were designing them to, game the test.
Pretty much. Ingenious, in a way. They evolved after they passed the test.
Incredible. But that kind of performance advantage couldn't last forever, I guess, what finally happened.
The party ended January 1st, 2011. The BBCOR R.50 standard took effect.
BBCOR.
BBCOR's big change was mandating accelerated break-in testing, or ABI. They basically beat the bat up in a lab before testing its performance.
Closing the loophole.
Closed it tight. It forced bats to perform much more like wood bats right out of the wrapper and staying that way. The super bat era was over.
So how did Easton respond? Did they just give up?
No, they adapted. In the BBCOR era, they developed new alloys like HMX, and they still found ways to innovate within the tighter rules. A really cool example is the Z-Core lock and load system later on.
Lock and load, what's that?
It let players swap out different weighted inserts in the end cap, so you could actually customize the bat's swing weight and balance point. Fine-tuning, even under BBCOR.
That's smart. Sting finding ways to optimize for the player.
Exactly.
So looking back, the legacy of C-Core and Z-Core is pretty clear, wouldn't you say?
Oh, absolutely. They were engineering marvels. They defined that whole high-performance era.
And the core ideas like reinforcing the barrel internally or the two-piece construction to kill vibration, you still see that stuff in bats today, right?
Definitely. Those principles became foundational. Even with BBCRR, designers built on that knowledge.
What an incredible journey then. Physics, materials, clever engineering, rule bending, all packed into a baseball bat.
They really were pushing right to the absolute edge of what was possible back then.
Yeah.
It makes you wonder, though, doesn't it? Thinking about strict regulations like BBCOR, how do they really impact innovation in sports gear? Do they just stifle creativity? Or do they maybe force engineers to be smarter, to find different, perhaps more clever ways to improve performance? Something for you to think about.
That's a great question. We hope this deep dive into Easton's C-Core and Z-Core era gave you some insight and maybe sparked some more questions.